J. NER JEE. হ্যাঁ NER কেন স্যার 0031 ফাহাদের 0019 আচ্ছা 13 রিভার্স ও হ্যাঁ 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 আচ্ছা হ্যাঁ হয়ে গেছিল হ্যাঁ 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 ঠিক আছে হ্যাঁ হ্যাঁ আচ্ছা ঠিক আছে ঠিক আছে হ্যাঁ হ্যাঁ বুঝতে পেরেছি হুম হুম ঠিক আছে সোমবারে তাহলে স্যার হ্যাঁ আচ্ছা ঠিক আছে হুম to all of you just let me know yeah fine so all right yeah hello Swam how are you okay so today we have a topic of applications of derivative as you can see on the screen so today we will basically get started with the CBSE previous year problems on the topic of applications of derivative right okay so yeah let's get started on this today's important topic and I'll basically show you that how crucial this particular topic of application of derivative is and how meaningful the applications of calculus is to the real life okay so this will be an interesting part to discuss about the calculus and its applications in its real life, right? So I will basically talk about the applications problems of geometry. We'll talk about the application problems of like different ways, right? Now you know that calculus has multiple roles and importance in the different fields of life, right? Even if you go on to work into the field of machine learning, you'll find out it's all about calculus and optimization, right? Now, what is optimization? Now, this is basically simply the word that you basically have been learning that maxima and minima. This is basically all about optimization, right? So you are basically doing nothing, but you are just optimizing for a given function, and this is something that you're going to do in even in machine learning, right? not only in machine learning, that is a very interesting field, but not only in machine learning, even someone who takes up economics or finance, they are also going to use the calculus or the probabilistic calculus in the field of stochastics and finance, right? So someone who is basically very interested to go into the field of economics or finance, they are also going to use the calculus part simultaneously, right? So there are multiple fields of calculus where you're going to apply, and today we're going to be seeing some of the basic applications of derivative and how we basically apply them to the problems of the real life, right? So today we have a topic of applications of derivative, and I will be the instructor for this course, right? So if you're someone who is new to this particular channel, please consider subscribing to this channel, and we are basically here to help all of people who are basically preparing for your CBSE examination, right? So if you haven't watched the previous lectures, you can definitely go to the channel, check out the live videos. So we have already covered probability, integrals, applications of derivatives, differential equations, and applications of integrals, right? So those are the very high scoring topics. Even we have covered vectors, we have covered 3D geometry. So those are really important and high scoring topics, right? So if you just prepare those topics very well, I can assure you that at least you can get 50 or more than 50 marks, right, in your out of 80. Now in order to get the remaining marks for your exams, you definitely have to prepare these particular small topics, right? Now application derivative is really important topic. Now I won't say it's a small topic, but it's a really interesting topic. Okay, so if you just are new to this particular topic, so please, I would recommend you, please try to watch this lecture till the end, and you will be trying to get at least something or the other where you can apply your ideas and concepts to the examination, right? So let's get started on this particular goal. So today we have a goal with us is the applications of derivative. We will try to understand this. We'll try to apply it to the real life. Okay, we'll try to understand what is the concept behind it. Okay, so main thing is basically what is the concept. Once you are able to apply the concept, you are basically going to apply it to the every problems. Okay, and we then going to visualize things. Okay, visualize things clearly, right? And after that we are going to apply the idea of derivative to the real life problems. Okay, that's what we're going to see over here. We have some case study problems that are basically very interesting for your CBSE examination. Okay, so and along with that we also solve some techniques for different solving problems. So I will tell you some techniques that you basically going to apply for solving different types of sets of problems, right? Now you know that in maths multiple problems can be approached in multiple ways. Okay, so that's what actually matters, right? And along with that we're also going to see the exam patterns and paper analysis. We are also going to do some paper analysis of that, right? So this is all we are going to discuss in today's session, so stay tuned for it. Okay, and if you feel these contents are useful and are meaningful to your life, definitely consider subscribing, and don't forget to hit the bell icon so that you don't miss out any content in the upcoming sessions, right? So we are definitely going to conduct many sessions before the start of the CBSE examination. So I know that you all have exam on 9th of March, so before that I will be coming out with every day with some content so that you are preparing better for the examination. So someone who is very haven't started preparation, also you can definitely start preparation with these particular lectures. Okay, so you just go through these lectures, you understand the set of problems that I'm basically going to discuss over here. If you are following those particular parts, you're definitely going to do better in the examination. All right, so that is it. Let's get started. So with the very first problem we have with us is a simple problem from the methods of differentiation, right? Now I took this problem because it was recently asked in the paper of 2024, right? Let's try to see what the question has to offer, right? So we have a given function, right? Let us call the function f of x, and let us see the function is sine of x square, right? Now we need to differentiate this particular function with respect to x, and I need to differentiate at x equal to square root of pi, right? So I need to differentiate at this particular point x equal to square root of pi, right? Now I have a given function. Okay, yeah, hi Subham. Yeah, okay, sorry. Okay, 8th of March. Okay, so don't worry, I will be taking up all the topics before the 8th of March. Okay, my plan is basically to go about with the remaining topics. That is basically I have some parts of like limits, continuity, differentiabilities left, right? And along with that I need to also discuss about the functions and relations. Okay, now that those are also important, but I would also be discussing those topics, and along with that I will be taking up the most high predictive scoring topics, and we'll also go with a one-shot lectures where we discuss all the chapters together. Okay, and we also have some revision lectures before 8th of March. Okay, so stay tuned for that. I will be basically there to help you all of people, right? So this will be an exciting opportunity to all to learn, and if you haven't started till now, this will be a great opportunity. Okay, So let's go about, right? So we have to differentiate at x equals to square root of pi, right? So let us see how we differentiate this. So we know that if we try to differentiate this f of x function with respect to x, I'm going to apply the chain rule over here, because if you see, it's basically sine of some function of x, right? Again, so sine of sine x, differentiation of sine x is basically going to be cos of x. So in place of x, I will have x square multiplied with chain rule into differentiation of x square, that is going to be equal to 2x, right? All right, so with this, I will get the answer as 2x cos of x square. Now, if I put the value of the derivative at x equals to square root of pi, I'm going to get the answer as 2 square root pi into cos of pi, and that is going to be minus 1. So that's how I'll get the answer as option C. No, Subham, you are incorrect. The answer is option C. Okay, differentiation of sin x is basically cos x. Okay, and cos pi is basically minus of 1, so cos pi is equals to minus of 1. Okay, so please make sure that you know this. Okay, all right, so the answer is going to be minus of 2 square root of pi. Okay, so we with this we will have the answer as option number C. Option C is going to be the right answer. Please correct your please correct it, Subham. Did you get it? Did you get it, Subham? All right, so I hope this problem was pretty simple, right? So one more thing that I would like to tell you. So whenever you are solving this questions for the CBSE examination, make sure that you clearly mention the steps, okay? And there is nothing to hurry about, okay? No one is going for all of time, right? You have entirely 3 hours to utilize, and the 3 hours is sufficient to solve each and every questions, okay? Right? Don't feel that the questions are going to be difficult, nothing like that. You just have to solve simply and clearly. Okay, so if you're mentioning all the steps clearly, maybe if you are putting the value as plus of 1, maybe still you will get a half marks. Okay, so this is a 1 marker problem. So if you are solving the steps, still you have a high chance to get the step marks. Okay, but if you are not showing the step and directly marking the answer, then you have no chance to get the step marks. So definitely, if you're marking the wrong answer, you're definitely going to get the 0 marks. Okay, so make sure that you actually clearly mention and all this do these things. Okay, now why I am focusing on the presentation part, because presentation is actually the key. Okay, so try to maintain this particular thing. Presentation is actually the goal in order to get a good marks or high marks. Okay, so this particular part is clear, right? So let's move to the next problem, and next problem we have with us is basically from the 2024 paper. So we have to solve for, we have given with a function. The function is mentioned as 4x cube minus 18x square plus 27x minus 7, right? So this is a definition of the function f of x, and we have to check whether this particular function has maxima or minima or not, right? So we have to show that this particular function has neither maxima nor minima, right? So how do we analyze a function which does not have a maxima nor minima, right? So if you just look at the nth derivative test, let us try to recall the nth derivative test, right? So let me tell you what is the basically the statement of any derivative test, right? Now in the chapter of maxima minima, when we were discussing maxima minima, we have a topic where we basically do the first derivative test. Now in first derivative test, we basically try to differentiate the function, and we try to figure out what is the increasing and the decreasing nature of the function, right? And at the interval or at the value of x where the function changes the nature of the sign, that is basically called as critical point. So around critical point, we try to analyze what is the behavior of its derivative, right? So from the analysis of the derivative behavior, we're basically going to predict whether we have a maximum or minimum or not, right? But yes, Shivam, you are correct. F dash of x is equal to 0, okay, not f of x is equal to 0, right? That is going to be a critical point, right? Okay, so what we basically try to do over here is that now in that particular problem, we are only try to analyze what is a maxima or minima, right? We are not having any clue about what is basically the whether we are having a point of inflection or not, right? Now you might be confused that what is point of inflection. So I will let you know that very simple example. So if you try to draw the graph of x cube, right? I hope many of you students know this graph, right? X cube. So at x cube, if you look at this point x equal to 0, so at x equal to 0, the tangent, the sign of the tangent doesn't change, right? So I have not maxima, not minima, but this is going to be a critical point, right? So if you differentiate x cube, so the differentiation of x cube is going to be 3x square, right? So if you just put x equal to 0, So if you see that x equal to 0 is basically going to be critical point, right? But the thing is like it is basically always positive, right? So it is always positive, that means it is an increasing function, right? Now if I differentiate it to second time, you will see that it is basically equal to 6x, right? Now at x equal to greater than 0, it is basically positive, right? But at x negative, it is basically negative, right? So this is showing that if the second derivative is positive or negative, that basically talks about whether we have a changing nature of the curvature, right? So you can see that at x equal to 0, the curvature changes, but not the derivative sign, right? That basically means it is a point of inflection. So at x equal to 0 for this particular function, we have point of inflection. Okay, you got the point of inflection as x equal to 3 by 2. Wait, okay, let's see. So yeah, let me continue with the discussion what I was talking about in a derivative test. So in this particular test, when we do it, we try to find out what is f dash of x, right? Now after we find out the critical points, now let us say I found the critical point as let us say I found the critical points as x equal to c1. Okay, now what I will do, I will try to check what is the derivative of x equal to c1. If it is equal to 0, if I'm having the derivative of c1 equal to 0, then I will proceed for the second derivative test. Okay, then I will proceed for the second derivative test, right? Is it clear? Now, if it is greater than or less than 0, then we are basically trying to understand whether it is an increasing or decreasing function, right? In that case, if it is an increasing or decreasing function, in that case, the maxima and the minima will occur along the endpoints or the starting or the endpoints, right? Or the domain of the graph, right? But what is most crucial is to try to analyze the second derivative, right? Now, in this second derivative, if we are putting the same critical point, if we are getting the value as negative, then it is basically a point of maxima, right? It is basically a point of maxima. And similarly, if I'm having the second derivative at that particular point as positive, then it is basically a point of minima, right? But there may be also a case when I have the second derivative at that particular point equal to 0, right? Now what if the second derivative at that point is equal to 0? Then we basically go to perform the third derivative test, right? So we then take out the third derivative, we try to see whether it is basically coming as non-zero or whether it is coming as 0, right? Now if it is non-zero, if it is coming as non-zero, then that particular thing is called as point of inflection. Okay, point of inflection. Okay, now if it is equal to 0, then we again proceed in the same way, right? So if it is equal to 0, we again proceed in the same way and we try to find the fourth derivative. So what do you understand is that now what is the crack of this particular thing is to understand is that now in the even order derivative, if you are having equal to 0, then we have to proceed for the further derivative, right? But in order derivative, if it is not equal to 0, then that is basically a sign that it is a point of inflection. But in even order derivative, if I am having positive or negative, that will determine the case whether I am having the maxima or minima or not, right? Is this clear? Is this clear or not? Please let me know. I'm erasing this part. It is clear or not? So let me erase this part of the explanation. I hope this particular explanation was simple and clear, right? We will try to apply this explanation over here. So let's try to analyze the question in terms of that. So first and foremost thing is basically to try to analyze what are the critical points. So if I just differentiate it once, I'm going to get it as 12x square minus 36x plus 27, right? So that is going to be my first derivative, right? So what I can do, I can take common, I can take 3 as common, right? So I will just have 4x square minus 12x plus of 9, right? If I take 3 as common, right? Now for critical point, for finding out the critical point, let me write it down. Now please make sure that it is a show that question. Okay, so you just mention all the parts clearly and write it. Okay, so critical point is basically the point where I have f dash of x equal to 0, right? So if I just equal to 0, I will get basically 4x square minus 12x plus of 9 equal to 0, right? Now this is basically simply a quadratic equation. You just need to solve this quadratic equation in order to get to the relation, right? Is it simple or clear? Right? So what we do, we try to factorize this particular quadratic. Okay, is this clear? Let me know. Yeah. So from here, you'll basically get two factors, right? So let us see what are the critical points I'm basically having. So the critical points are basically going to be equal to, so if you just check the critical points, you will basically get up the roots as complex, right? So what I would say instead is that you just try to first of all try to find out what is the discriminant of it. Okay. Now if you just look at the discriminant from the nature, which is basically equal to b square minus 4ac, right? So if you just calculate the discriminant from here, you basically get 144 minus 4 times of 4 into 9, right? Okay. So this discriminant is going to be equal to 144 minus, now this part is going to be equal to, so 9 into 16, right? So if you just check what is 9 into 16, right? So it is also going to be equal to 144, right? Is it clear? So we are basically going to have the discriminant as equal to 0, right? So we will basically have one root. Yes, correct. Yes, Shivam, you are correct. The point of inflection is equal to is 3 by 2, right? Because that is the critical point. Yes, correct. So we will have the critical point over here as 3 by 2, right? You can check. Okay. You can try to simplify this part. It's very simple, right? So we'll have only one root, and that is basically the 3 by 2, right? Now you have to basically prove that this is basically the point of inflection. It is not the point of maximum minimum, right? So what we'll do, we try to differentiate it again. So if we differentiate this part again, so we're basically going to have 3 as a common. So we differentiate it again, we're going to have 8x minus of 12, right? Now if you just differentiate this again, now what you see at the value of x equal to 3 by 2, this particular thing is equal to 0, right? It is 0, right? Now what you understand that at the value when it is greater than 3 by 2, so I have written 3 by 2 plus. So what is basically mean by 3 by 2 plus? 3 by 2 plus is basically meaning that it is basically greater than 3 by 2. So if it is greater than 3 by 2, I will have this as positive, right? And similarly, if this value of x is less than, so it is basically tending to 3 by 2 minus, then I will have the second derivative as negative, right? So that shows that at x equal to 3 by 2, this particular function f of x basically changes its curvature. So whenever a particular function is changing its curvature at a particular critical point, then that is a point where we classify that particular point as inflection or point of inflection, right? So this is very simple, right? So that's how you're going to prove that this particular function is neither has any neither maxima nor minima, right? Right? Is it clear or not? So we can just simply write this equation as 2x minus of 3 whole square, which is obviously greater than equal to 0, right? So it is always an increasing function, right? So you can see it is always an increasing function, right? So that's how you're going to prove this particular part of the question. Okay, simple, clear. All right, so with this, let's move to the next problem. And next problem we have again from the 2024 paper. So it is a problem where you're basically going to analyze a case study based problem, right? So this is a very interesting case study based problem. Now, with this particular problem, I'm going to show you how you are going to apply your concept of application of derivative to the real life problems, right? Now, this is a very simplified version of a real life problem, right? So let us try to analyze what is this particular problem has to offer, right? Got it? Okay, so let us see what this particular problem has to offer. So we have a question where we said that the traffic police has installed a overspeed violation detection camera or system, right? And what does it do? It is basically installed in various locations in the cities, and this camera can capture a speeding vehicle from distance of 300 meter. Now very interesting. It can capture the speeding vehicle at a distance of 300 meter, and even the function in the dark. Okay, it is not even a function of light or dark, it can even function in dark as well, right? Now what is basically mentioned, it said that a camera is installed on the pole of a height of 5 meter, right? So you can see what I'm doing while I'm reading the problem, I'm basically trying to highlight the keywords. So what we can see, it is basically able to find a vehicle speeding at the 300 meter. The camera is installed at a height of 5 meters. So those are the keywords which are basically the giving me the input for the given question, right? And it detects a car traveling away from a pole at a speed of 20 meter per second. right? So it detects a car which is moving from the pole at a speed of 20 meter per second, right? Now you can see the diagram is also given over here just to explain the fact that what is basically meaning the question, right? Now at any point x meter from the base of the pole, so let us say at any point x meter from the base of the pole, so this is a pole where the camera is installed. So at any point x away from the base of the pole, the angle of elevation of the speeding camera, the angle of elevation of the speed camera from the car. So what is basically mean by the angle of elevation over here? So if we just look at our primary focus or definitions, okay, primary focus or definitions of the initial trigonometry. So in application of trigonometry, you must have understood that angle of elevation. So for example, this is our initial side, right? This is our initial side, right? Now with respect to initial side, if we are measuring or try to look at some other particular point, now this particular point is called line of sight because we are looking, right? So with respect to one particular, okay, with respect to one particular initial or fixed base, we are basically trying to analyze a particular object. So this is our line of sight, right? Now whenever you are observing, so this is your observer, okay? So this is the eye of the observer, okay? This is the eye of the observer. So at the eye of the observer, the line of sight, that particular angle, if we are measuring that angle in the anti-clockwise direction, that particular theta is basically called as angle of elevation, right? Is called as angle of elevation. Is it clear? Now similarly, if the line of sight is basically below this axis, then we call this particular angle as angle of depression, okay? Now this is something very simple nomenclature from your initial applications of triangles or the applications of trigonometry to triangles, right? This is something I've learned in heights and distance, okay? So it is said that this particular angle of elevation over here, this particular angle of elevation over here is basically given as theta, okay? So if I have this theta, so on the basis of the following information, it is asked in the problem, try to answer the following question, right? So first of all, it is said that you have to express theta in terms of the height of the camera installed and on the pole and the distance x. So if you look at this particular right angle triangle, if you try to look at this particular right angle triangle, in this particular right angle triangle, you will find out that theta. So if you just do this on the next page, so I can simply write the first information. So on this particular pole, right? So the height of the pole is basically mentioned as 5 meter, right? And I have this particular distance at any instant as given as x, right? This is our card. This is our card, and this particular angle is given as theta. So from this particular right angle triangle, we can simply write or express tan theta as basically 5 upon x, right? Clear? Now if we understand this part, now our next part is basically said in the problem is that find d theta upon dx, right? Now how we basically get d theta upon dx? Now if we differentiate, so the second part, we will get the d theta upon dx, right? So if we just differentiate, both the sides, both the sides, what I'm going to get it as, so let us try to first of all express theta. So theta is basically given as tan inverse of 5 upon x, right? That was basically asked in the problem to express theta, right? So I have expressed theta as basically tan inverse of 5 upon x, right? Now if we just differentiate this particular part, I'm going to get d theta upon dx as basically 1 upon, what is the differentiation of tan inverse of x? It is basically equal to 1 upon 1 plus x square, right? So that is going to be a differentiation of tan inverse of x, right? So that is going to be equal to 1 upon 1 by x square, right? So from here I will get it's 1 upon 1 plus 5 by x whole square multiplied with differentiation of 5 by x, and differentiation of 5 by x is going to be minus of 5 upon x square, right? So if you just simplify this part, we are going to basically get d theta upon dx, as simply as minus 5 upon 525 plus x square, right? As simple as that, right? So that is what we get as d theta upon dx. So we have solved the first two parts, right? Now the next third part of the of this problem says that find the rate of change of angle of elevation with respect to the time at any instant when the card is 50 meters away from the pole, right? So it is said that we have to find out the rate of change of elevation, right? So in the third part, it is said that we have to find out the rate of change of elevation with respect to time, but we have the rate of change of elevation with respect to the space or this particular distance x equal to, right? So it is also said that we have to find the rate of change of this elevation at respect to time when the x is basically mentioned as 50 meter, right? Now we know from the basic of your derivative, we know that we can write this particular d theta upon dx. So d theta upon dt as d theta upon dx multiplied with dx upon d theta dt, right? Just by using simple chain rule, right? So we can express this particular part as that. Now we know what is the value of the d theta upon dx, right? We know what is the value of d theta upon dx, so we can simplify it as minus of 5 upon 25 plus x square, right? And dx upon d theta is nothing but it is the speed of the vehicle. It is the speed of the vehicle. Now what should be the speed of the vehicle? So what is the speed of the vehicle? Now the speed of the vehicle, so what we can see, it is moving at a speed of 20 meters per second, right? So it detects a car moving out from the pole at a speed of 20 meters per second. Is it clear? Okay, so is this plot clear or not? Let me know. So it is multiplied into 20 meter per second, right? So if we just simplify by putting x equal to 50, we are going to get minus 5 divided by 25 plus 50 whole square, right? 50 whole square is going to be 2500, right? And multiplied with 20, right? So that is going to give me the answer as so I have got the answer as equal to minus 4 upon 101 radians per second, right? So I have got this particular answer. Okay, please let me know, are you getting the same answer? Is this correct or not? Is this clear? Very simple problem, right? So we got out the value of the rate of change of angle of elevation with respect to time, right? At any given instant when the car is 50 meters away from the pole, right? Now in this third part, we also have one more part. If the rate of change of angle of elevation with respect to time of another car at a distance of 50 meters from the base is given as 3 upon 101 radian per second, then what is the speed of the car? It's just a reverse problem, right? So we have found out that d theta upon dt is basically minus 5 upon 25 plus x square into the speed of the car, right? So speed of car, that is basically mentioned as dx upon dt, right? So we have to find out dx upon dt given that we know the what is d theta upon dt. So d theta upon dt is given as 3 upon 101 radian per second. Now I'm again repeating, please don't forget to make sure the given units in the problem, right? If you're forgetting to write the units in the problem, you're definitely going to lose some marks. Okay, so it is mentioned as 3 upon 101, and we just need to, and it is said that it is also at a given distance of 50 meters. So we are going to get it equal to minus 5 upon 2525 into the speed of the car. So the speed of the car from here, we can easily find out this by dividing this part, right? So what we will get over here is that the speed of the car, I will get this as equals to minus of 15. Okay, so that is what I will get. If you just simplify this part, we are going to get this answer as minus 15 meter per second. Now what is this minus 15 indicates? Since we are basically trying to talk about speed, this basically talks about that we are basically approaching the answer in the opposite direction, right? So this part is clear. This part is clear. So we basically get it minus 15, which basically indicates if the vehicle is moving in the opposite direction, right? Okay, so let's move further then. So this is simple problem, right? So we can see that this was a 4 marks problem. Okay, so 4 parts of the question, so we will have 4 marks for it. Okay, so each of the parts were having 1 marks each. Okay, so the way you have to solve it, I have shown you the clear definition and I have explained you how we basically approach the problem, right? So it's a very simple problem. We basically use the application of derivative to capture or try to understand the problem, right? Very simple, straightforward, right? So let's get started on the next problem. And next problem we have with us is basically a question, which is a question from the increasing decreasing nature of the function, right? Now how to solve this problem? Now you will write the given function f of x is given as x minus sine inverse of x. Okay, x minus sine inverse of x, right? So it is said that we have to find out that particular interval of x for which I will have a decreasing function, right? I will have a decreasing function, right? So how to find out increasing decreasing nature? So let me tell you that for a given function, if it is an increasing function, what we try to see that the slopes. Okay, so let us take a simple graph of function to explain you this. So you can see this is an increasing function, right? Now what you are trying to understand, at each and every interval, if you try to calculate the tangent, the slope of the tangent, it is basically going to increase. Okay, so at each and every interval on the graph, if you are finding out what is the tangent we are getting, we find that for the increasing function, dy by dx should be greater than 0. And similarly, for a decreasing function, like this, so if you just find out derivative at each point, so you will find that the derivative is basically that dy by dx, so the slope is basically going to be negative, right? So that basically proves that whether it's an increasing function or a decreasing function, right? Now in this particular problem, we have to find out why it is basically decreasing, right? So for decreasing function, I just need, first of all, I will calculate what is the first derivative, right? So the first derivative of the function is going to be 1 minus 1 upon square root of 1 plus x square, right? So 1 plus x square. Now, right, so this is what we have for the f dash of x, right? Now we have to find out this particular interval of x where it is basically is negative, right? So we have to check for decreasing function, so this will be negative, right? We have to check for decreasing interval, right? So now from here I will basically get it as 1 upon square root of 1 plus x square should be less than 1, right? If it is less than 1, then only it is negative. Or did I do any mistake? Sorry, it should be greater than 1, right? It should be greater than 1, right? Yes, it should be greater than 1. Then only you will have negative, right? If this particular number is greater, then this will be negative, right? Yes. So now what you know further is that now how to basically solve this particular part, right? Now you know that square root of any term is basically always positive. So you just take it on this particular side and we shall solve it. So this is where you get it. 1 is greater than square root of 1 plus x square, right? So if we just try to simplify, we're basically going to get it as, so if you take square of both the sides, so you will have 1 is greater than 1 plus x square. So from here, this x square is less than 0, right? So from here I will get a simplified answer as inequality as x square less than 0. Now for which value of x we are basically having x square less than 0? In real x we do not have any such values, right? For which we have x square less than 0. So therefore our final answer to this particular problem is definitely going to be this part, that is option number D, right? That is no value of x is there for which I will have this particular function decreasing, right? So this particular function x minus sine x is always increasing. Now this is, you can also prove this by this fact that we know that sine x is always less than tan x, right? This is always true for all x belonging to real part. Is this clear? Or not? Right? So for all x belonging to real number, this particular inequality is always satisfied. That is sine x is less than tan x. Okay. So from this particular inequality also you can see that x minus sine x is always increasing function. Okay. Right. So this part is clear, I hope. Alright. So if this part is clear, gives me a thumbs up in the live chat. Give me a thumbs up. Okay. If you have any confusion, you can still ask. Okay. Now someone who will be watching this lecture in the recorded format after the live class is over, so definitely they can also put that as the comment in the comment section. Okay, I will be definitely looking at your comments. Okay, so please make sure that you solve the problems correctly, you try to understand the problems and you try to get to the answers. Okay, you just do not try to mug up the answers as given in the problem. Okay, please try to understand the problem, that the steps I'm basically showing, that is very crucial to all of the students who are basically trying to understand. Okay, if you start to understand this particular problem, you definitely get the question is very simple. Okay, the questions are really simple. You just need to understand the step-by-step method I'm basically solving it. Okay, now I would also request all of you students to basically, after the live session is over, you can please take up the questions and you can start to solve it by yourself. Okay, You just try to approach these problems by yourself. Okay, at least try to see like whether you are getting the answers or not. Okay, that will actually help you a lot. Okay, in preparing for your actual examinations. Okay, so let's move further then. Okay, now again we have another question of increasing decreasing nature. So we have to basically comment on what is the interval of x for which I am having it is a decreasing function, right? So we have f of x given as 2x cube plus 9x square plus 12x minus of 1, right? So we have to find out again the interval of x for which it is a decreasing function, right? So again we want to do the derivative and equate it to, or inequality should be less than 0, right? So the first derivative, if we try to find it out, we are going to get it as 6x square plus 18x plus of 12, right? Now from here I can take 6 as common, so I will get 6x square plus 3 plus 2, that is going to be the relation. So we can simply factorize this part, right? So I can write it as x plus 2 into x plus 1, right? Now I have to equate that to less than 0, right? For decreasing interval I just have to find out this particular inequality, right? So this is a very simple inequality. So if we just do the Vevicam method, we can simply put the critical points as -2 and -1, and if we just look at the positive nature of sign is given there, so it will be plus, minus and plus, right? So this is from the Vevicam method, and we have to find out those particular interval where it is negative, right? So that is the given interval. This is going to be the interval -2 to -1. So our ultimate value of x should be basically between -2 to -1, for which I will have this function as decreasing function, right? So from here you can simply see that the answer to this particular problem is going to be option number B, that is going to be -1 to -1. And you must have to understand that it is going to be in an open interval, right? So we are basically saying that it is decreasing function, right? We are not saying whether it is strictly decreasing or strictly increasing, that is nothing is mentioned, but you can look at the options. The option is also pretty clear in the terms of open interval. Okay, so it is basically talking about strictly decreasing. Okay, now what is basically mean by strictly decreasing and strictly increasing? Let me clear this confusion. So strictly increasing function is that its function is always increasing for all values of x, right? So for strictly increasing function I should have f dash greater than 0, but there might be a function like this way, that it is basically giving constant then increasing, right? So for this particular function the f dash of x can be greater than or equal to 0, that it can also be equal to 0, right? At this particular interval it is basically equal to 0. I hope this particular confusion is clear, right? For strictly increasing function I definitely must have the value of f dash of x should be greater than 0, right? Right, is it clear? Is it clear? Okay, so I hope this part was clear enough, right? So we saw that there are questions from the increasing decreasing nature, so please make sure that you remember the formula. Okay, so for increasing function the f dash of x should be greater than 0, for decreasing function f dash of x should be less than 0, right? Now I'm not showing you the how the way you are going to write it out, so please make sure that you know how to proceed, right? Right, so first of all make sure that you write the given function, then try to write the decreasing function. For the condition is f dash of x should be less than 0, then you proceed further with the calculations. Okay, so step by step calculation will actually fetch you the full marks. Okay, now the next problem we have with us is basically again a very interesting application based problem. So it is said that there is a wire. Now you know that wires are mostly straight lines, right, or linear. Okay, so it is basically said that there is a wire which is of length 20 centimeter, right? So it is said that there is a wire of length 20 centimeter and it is bent in a form of a sector, not a circle. It is bent in a form of a sector of a circle. Okay, so in a circle it is basically bent in a form of a sector, right? So it is basically bent like this way. Okay, now we have to analyze this particular maximum area that can be enclosed by this particular wire. Now what do you mean by maximum area enclosed by the wire? So if we understand this from this problem, the problem says that we have a we have a wire of this particular length and it's bent in the form of sector, right? So it is said the maximum area that can be enclosed by the wire is basically talking about the area of this particular sector, right? So it is basically talking about this particular area that it can enclose, right? So if we try to form this wire in a form of circle, and since we cannot make this entirely a circle, that otherwise it will be very small circle, but it is said that we have to make it a sector. So if we just make it a sector, what is the area enclosed by this particular wire? Let us try to find out, right? So if we just look at this particular length is a length, right? Now if this angle is going to be theta, if this particular angle is going to be theta and the radius of the circle is going to be r, we know that the length of the sector, or the length of the sector or arc, we call this arc length. Okay, that is basically going to be r into theta, right? R into theta, where theta is basically given in the radian, right? So So this particular length should be equal to the length that is basically mentioned, that is 20 centimeter, right? Now we also know that the area of a sector is basically given as r square upon 2 into theta. Now how do we get this, right? This is a question. So let us try to analyze and how we basically get this. So tell me, what is the area of a circle? So area of a circle is basically equal to pi r square, right? Now we have to use some unitary method over here. So area of a circle. Now this is basically the area of a circle when the entire angle, the center is 2 pi, right? Or even antipole of 2 pi. So whenever we have an entire circle, it is 2 pi. So for example, if I have a circle where the angle is 1 radian, then I will have the area as 2 pi r square divided by 2 pi. And if at the angle is theta, then the area will be given as pi r square divided by 2 pi into theta, right? So from here you will basically get pi cancel, so r square by 2 into theta, so that is going to be an area of a sector, right? Now from here I can just replace theta. So from here I can replace theta as L upon r. So L is constant, which is mentioned. So area of a sector is basically going to be r square by theta by 2 into theta. Theta is basically given as L by r. So with this I will get this as LR upon 2, right? That is going to be my area. Now I just need to find out what is the maximum area, right? So in order to get to the maximum area, I'll just need to differentiate this with respect to r, right? Because r is the unknown, L is the constant. So from here, if I just differentiate this, so I have to differentiate this dl upon dr. So if I just try to differentiate this with respect to r, I will get this as L upon 2, right? Which is a constant, right? So we find out this is a constant which is greater than 0, right? So it is an increasing function, right? So definitely we have to find out the greatest value, right? Now if you just differentiate the second time, you are going to get the answer as 0, right? Now this is a very interesting question. It's an increasing function, right? So what we can do, we can try to put the value of r, which is the maximum over here, right? Okay, so what we'll do over here, so we will put the value of that particular r for which we are having the maximum radius, because it's an increasing function, right? I hope this part is clear. Please let me know in the comment section. So I think the steps are clear, and with this you can move forward with the questions. Okay, so what is the correct answer? Let me know. So what's the correct answer you're getting? So what is the correct answer you're getting? Okay, so I leave this particular problem with this part as a homework to you. Okay, so please let me the correct option in the comment section. Okay, please solve this part clearly and complete it, and tell me what is the correct answer or option you are getting from this particular part. I hope the explanation is simple and clear enough, right? So I actually want you to solve this problem. Now since it's an increasing function, it's very simple, right? We don't have to do for the second derivative, right? With this, let's move to the next problem. And again, we have a problem where we basically have to find out what is the least value of a function, right? Now, this is a question of maxima and minima, right? So we have to find out the minimum value of the function, right? So if we look at the function, it is basically given as 2 times of cos of x plus x, right? It is basically given as 2 times of cos of x plus x. Now, in the interval 0 to 2 pi by 2, we will talk about what is the minimum value I have for this particular function, right? So if we just try to find out what is the derivative, let us try to find out what is the critical point, right? So it is going to be equal to minus of 2 times of sine x plus of 1. Now if I just equate it to 0, I'll get the critical point as sine is equal to 1 upon 2. So from here I will get the critical point as pi upon 6, right? Which is basically inside the interval, right? So at this critical point, let us try to plot what is the behavior of this first derivative, right? So at pi by 6, and we have 0 and pi by 2, right? So in between 0 to pi by 6, we will see that this particular term will dominate, right? Now if you just look at this, is basically the so we are basically looking at the sign scheme of f dash of x. Okay, so this is the f dash of x, right? So if you just look at that term in between 0 to pi by 6, this particular term, the one term is going to dominate, right? So this is going to be basically 1 minus something, that is going to be positive, right? Now and when this particular part is between pi by 6 to pi by 2, this particular part is going to be dominant, right? So here I will have minus sign. So you can see that from when the given function transit from a negative to positive, sorry, positive to negative, so it is basically giving me the maxima, right? And if it is basically transiting from negative to positive, it will basically give me the minima, right? So now you can see that at pi by 6, it's basically a maxima. We can also prove this part by doing the second derivative. Okay, so if you just take the second derivative, you are basically going to get the answer as minus of 2 times of cos of x, right? Now at pi by 6, you are definitely going to have this answer as minus, okay, minus 2 root 3, okay, minus root 3, which is basically a negative value. So if you see the second derivative is negative, that basically shows that pi by 6 is the point of maxima, not minimum, but we have to find out the minimum value. So what we do over here, we'll find out the values of the endpoint. So if you just try to find out f of 0, it is basically equal to 2, right? And if you find out what is f of pi by 2, it is basically equal to pi by 2, right? And pi by 2 is basically 1.57 and f of 0 is basically 2, right? And if you just find out what is pi by 6, this is basically going to have it as, so at pi by 6 I will have it as root 3 plus pi by 6, right? Root 3 plus pi by 6. So from here, you'll find out that the minimum value will occur at the endpoint pi by 2. So that is basically equal to pi by 2, right? So our answer to this particular problem is simple and it is basically option number C. Is this clear or not? Let me know in the comment section if it is clear or not. Right? Very simple problem. Okay. So with this, let's move to the next problem. And next problem again is a case study based problem. So if you just look at this problem, there is a field or a sport field in which is given in the form of a ellipse, right? Now, I actually want you to give this particular problem as a homework problem. Okay. Now, why I'm giving this problem as a homework problem? Because I want to analyze and try to make sure that you are also understanding the way to solve a case study based problem, right? Now, I will discuss this problem later. Okay. Now, please let me know if you are able to solve this problem on your own and let me know the answer, what you are getting in the comment section. Okay. First of all, if you are able to get the answer, if I am having basically the answer from any one of the students, I will understand that you are basically getting it, right? So, we can take up this question in the later stages. Okay. Now later we also have some more classes or where we basically discuss about the doubt or the homework problems. Okay, because we have given some homework problems in the different topics also, right? From probability, right? From integrals, right? From vectors, we have given some homework from 3D geometry. So those homework problems I can take up in one more class. Okay, where we basically discuss about those problems. Okay, but for the time being, please try to read the problem and try to understand that what we basically have to do. So here what we can see that there is an ellipse, and inside the ellipse and inside that particular ellipse we have to basically inscribe a rectangle, right? Now for getting the rectangle of the largest, so it is basically said that inside an ellipse we have to basically make the football ground. Okay, the soccer ground is always rectangular in shape, so we have to make the maximum length of the soccer ground, right? So that is what the question is. So very simple problem, very interesting problem. Now what you have to understand is that you can only inscribe a rectangle like this particular fashion in order to get to the maximum, right? So you basically consider this particular length as x and this particular length as y. So we basically going to get this particular total length as 2x, this total length as 2y, right? And we try to get x and y in terms of the other so that we can differentiate in only one variable. Okay, that is what is basically meant the problem. Okay, very simple problem, very straightforward, right? So first is mentioned that you have to find out what is the relation between x and y. Second is critical point, and then we have to find out the derivative. Okay, so using second derivative test, we have to find out what is the maximum and minima. Or you can also use the first derivative test to find out. Okay, so there is an or over here. I hope you can see. Now, you know, the motivation for this particular problem is basically from this particular problem, which was already asked in 2019. So you can see in this problem also, it is said that inside an ellipse, you have to find out the area of the greatest rectangle that can be inscribed, right? So you can see this particular problem got repeated in this particular case study problem, right? Of 2022-23. Okay, so I hope this particular problems are clear and simple, right? So you just have to apply the simple concepts of your maximum minima, right? So with this, I am basically at the end of this particular session. So I have discussed a lot of problems and we have discussed some of the concepts, what are very important concepts. So I hope you will remember this particular concept for the chapters of applications of derivative and you will come up with the ideas. Okay, so with this particular session, I hope I was able to make sure I was able to give you some ideas that are basically crucial for solving problems of different sets. Okay, so I hope this was clear, right? So today's session was clear enough. So if you like this video, don't forget to like this particular video. And if you find this particular kind of content is meaningful to your life and you are basically helpful, please consider subscribing to this particular channel. Okay, and do not forget to hit the bell icon because that will basically give you updates about the latest sessions that we are basically going to conduct. Okay, so we are definitely going to come up live again with other topics. So we have topics coming up as limits, continuity, differentiability, and we have topic of functions and relations. Okay, so that with that I will be covering the entire syllabus of CBSE for class 12th. Okay, So someone who is basically new to this channel, please consider subscribing. Okay, so with this, let's end our session over here. So I wish you all the best, and you please make sure that you make short notes and revise the chapters accordingly. Okay, thank you.